Bro, to be honest, you shouldn't even try to believe everything you see on TV or in a movie because generally it's made up by people who just want, butts in the seat for the most part, guys. I mean, there's no real, education like that happening in films these days. Everything is just meant to follow a trend, right? So if they say, hey, listen, space is freezing and space is also hot and all these other crazy things, you have to look at it like, yeah, it is, but what does that have to do with me? Okay. Like specifically, if you were thrusted outside of some type of craft, let's say, without any type of protection, first of all, you're gone. Okay, let's just start right there. You are gone. You don't have to worry about the heat or the cold because you're not going to make it. The vacuum in space itself is going to completely withdraw the oxygen from your body almost immediately. Ooh, and if you were there, thrusted out, let's say, on the sun side, you'll be sitting at roughly 248 degrees Fahrenheit. If you were on the shadow side, you're at like negative 454 degrees Fahrenheit. That's basically almost absolute zero, okay? But there's no air there. There's also not much matter or any type of like serious amount of particles that can even convey the heat to your body like that, right? So you're pretty much not going to freeze or like burn instantly. It'll just happen eventually, basically after you're extinct because your lungs basically collapsed. Okay. All right. So don't worry about the heat or the cold, guys. Don't do that. Don't do that at all. Right. But anyway, let's go and check this out immediately. See where this video takes us. Simon Whistler, of course, yes. Do it.
Did the tagline for Alien, "In space, no one can hear you scream," refer to the notion that no one is around to hear you scream at that alarmingly frisky facehugger, or to the fact that sound waves don't do particularly well in a vacuum? This won't come as a shock, but Hollywood tends to take more than a few liberties when it comes to accuracy, especially as far as outer space is concerned. The fact is that the vast, almost completely unexplored territory beyond our planet is a rather complicated beast to represent, and since most Hollywood writers don't possess the prerequisite PhDs, movie outer space is sometimes more fiction than it is science. Now, that isn't to say that Hollywood writers aren't trying, it's just that real outer space is often far more difficult to depict than even the most outlandish of fantasy films. So, today, we'll bust some myths.
All right, let's go. Sound, number one, sound does not exist in a vacuum. There's no oxygen to carry the sound. So, there's no sound in a vacuum. Like if we were to flood the area around our planet with oxygen somehow, we would go deaf, most likely in, I'm going to give it 10 seconds if you're not wearing ear protection, okay? Like, all of these planets are loud. All of them are. And the sun is screaming at you all day long. But, let's do it.
The reality of outer space is that you can't hear much of anything due to the lack of atmosphere. So, any movie that depicts the roar of spacecraft engines or the boom of cosmic explosions is, well, just plain wrong. Right. Sound propagates via molecular vibrations using primarily air as its medium. Tightly packed air molecules collide with one another when disturbed, sort of like the chain reaction that occurs when someone in a tightly packed crowd pushes the person in front of them. Only in the case of air molecules, there is rapid oscillation back and forth, creating the wave pattern that we recognize as a sound wave. The wave moves at the speed of sound, 343 meters per second, until finding a path to our eardrums. For a good visual representation, throw a rock into a pond. Water ripples are surprisingly accurate representations of sound waves. Now throw a rock into an empty pond to see why you can't hear anything in a vacuum. Of course, if we're being nitpicky, space is not a complete void. There are some rare particles floating around, primarily gas and dust, but certainly not enough to transmit sound waves. Further, in the spirit of being nitpicky, it isn't that sound doesn't exist in a vacuum at all. The astute will have realized that technically all molecules can act as a medium for sound, including the original vibrating object itself. Take the example of an outer space anvil struck with a hammer. That ringing anvil itself is making plenty of noise, it just simply can't transfer the sound to adjacent molecules because there aren't any. On a similar note, if a tree falls in the woods and no one is around to hear it, that tree doesn't make a sound. Sound only exists, by definition, if there's eardrums to sense the molecular fluctuations.
Or a trail cam. That's it.
So, without sound in space, many outer space
Explosions in
movie
space.
explosions already have a lot to answer for. But as misleading as sound design can be, it's the least of the average
Yeah.
Hollywood space explosions and
context, yeah.
accuracies. First
Like, why are they so large if there's no... okay.
foremost, can there even be explosions in space given that there's no air? Well, yeah, there can be certain types of explosions in a vacuum, namely from high explosives. At their core, all explosions are simply the rapid release of potential energy, and while all rapid releases of energy tend to go boom to some extent, not all of these reactions are created the same way. The burning of black powder, for example, is referred to as deflagration, or the rapid consecutive burning of a fuel. A high explosive, on the other hand, such as C4, detonates rather than deflagrates. Detonation is characterized by an explosive material instantly releasing all of its energy via a shockwave. Notably, explosive shockwaves travel at a much faster speed than the speed of sound, propagating through atmosphere and solids in a strikingly similar way. But put the pieces together and you'll realize that, like sound waves, shockwaves don't do particularly well in a vacuum. So what we're left with is a soundless space explosion with nowhere to go. Not exactly a flaming Death Star-worthy affair. On the other hand, all of that doesn't mean that a high explosive can't be destructive in a vacuum.
Oh, yeah,
It's just that the
incredibly
transfer of energy
destructive.
will be limited to directly adjacent materials, such as the spacecraft our C4 is assumedly detonating in. Thus, expect the spacecraft to still be torn to shreds and the pieces to still be propelled into deadly shards of shrapnel. Now, speaking of shrapnel, you've probably noticed that flying bits of debris on Earth tend to quickly land back on the ground.
Yeah, not
in
these.
a vacuum, however, there's no air resistance standing in the way of shrapnel and a virtually infinite journey into the unknown. Or at least until the shrapnel smashes into another physical object.
Right.
This means that the explosion you're seeing in outer space, perhaps hundreds or even thousands of kilometers away, may still kill you. Only as it'll be after a few hours, days, or weeks, though, when the shrapnel eventually plows through your spaceship. At that point, you're probably going to want to be wearing a spacesuit lest you join the handful of others that have experienced their blood boiling in a vacuum.
The human body will freeze or explode in space. I do think that eventually it'll freeze because once the heat radiates away from you, because that's the only way that you're going to freeze, bro. Like, there is no conduction or like convection, not like that. Again, because lack of particles, atoms, and molecules, etc. Right? In space. Explode, though? What do you mean by that? Like, yeah, I don't know about that one either, bro. Not in the way that they're, I would say more like, shrink in on itself, but either way.
Depending on which film you're using as reference, landing up in space without a suit is amongst the most horrendous ways to die. Your eyeballs may burst out of your head, according to Total Recall, or you may land up instantly freezing, according to Mission to Mars. As far as instantly freezing in space is concerned, once again, there is no atmosphere in a vacuum, meaning that heat transfer doesn't occur as it does on Earth. On Earth, we experience temperature primarily as convection or conduction, the transfer of heat with gases such as air or the transfer of heat with nearby solid objects.
Right, like, so the only way you're going to basically freeze is, again, once the heat completely radiates from your body. That's it. That's it. I mean, yeah, space is cold, right? But again, it's cold on the scale, let's say, right? But if you're exposed to it, it's not even going to hit you fast enough. Like, the vacuum of space is going to demolish you before you freeze.
In space, the primary temperature you're going to experience is thermal radiation from nearby stars. Hence, if you're unlucky enough to be without a spacesuit, you would certainly feel cold if you were in the shadow of a planet, or hot if you were in the eye line of a star. But key to our myth, neither temperature reaction would be very dramatic or instant. In the case of the protruding eyeballs of Total Recall, the filmmakers obviously believed that violent decompression occurs in a vacuum. But you might be astonished to learn that the human body is well capable of handling a pressure differential of 1 atmosphere. To put it in perspective, every 10 meters you dive underwater equals a 1 atmospheric pressure difference. So, since you don't see scuba divers abruptly being crushed into sardine cans, you won't be exploding in outer space. Air in your lungs, on the other hand, is going to want to expand rather rapidly into your chest cavity, resulting in ruptures. But don't panic, if you breathe that air out fast enough, you should be okay, at least until the liquid in your body starts spontaneously converting to vapor via ebullition.
What happened? Guys. Oh no.
A rather horrifying thing to imagine, refers to a process that occurs when air pressure gets too low, consequently dropping the boiling point of liquid to room temperature. You may have heard that your blood boils in space, and that is why. It's not actually due to any changes in temperature. Regardless, the longer ebullition is allowed to occur, the more destructive it will be, resulting in swelling, bruising, and the formation of gas bubbles in your bloodstream.
And you're
all
done.
rather gruesome, all not instantly fatal. Instead, you're going to die in outer space for the most obvious reason: asphyxiation. It will be perhaps a minute until deoxygenated blood is delivered to your brain, at which point you'll pass out and die soon afterwards. If someone does indeed plan on saving you, they have perhaps a minute and a half to 2 minutes. The good news is that you may recover without any serious injuries, depending on how long you endured the vacuum.
What? The sun is a burning, fiery ball.
According to more than a few Hollywood movies, stars are just massive fiery balls in space. Well, not only are stars not actually burning, at least not like a piece of paper burns, they also aren't yellow, or they're mostly not yellow.
Isn't the sun white?
We'll get to that in a minute. Fully understanding stars is an extremely complicated topic, so let's just do a bit of a crash course, shall we?
Right, let's go.
Clouds of mostly hydrogen gas and dust particles gather in space, appearing as a nebula. The dust and gas particles within nebulas sometimes clump together, be it due to a nearby planet's gravity or perhaps just due to natural oscillation within the cloud itself. Either way, critical mass is achieved and the particles collapse to a point. In this way, a mass is formed large enough to produce its own gravity. The new gravity, in a process called accretion, gradually drags in more dust and gas. During accretion, a number of interesting things may happen. Multiple protostars may form, as well as multiple protoplanets, depending on conditions. Most important to our story today is that once a protostar gathers enough gas and dust particles, creating immense pressure and heat at the center, nuclear fusion occurs. The entire mass is then said to go nova. If you're unfamiliar with nuclear fusion, this refers to atoms being forced together with such immense pressure that they fuse and create a new atom. In the case of a star, helium fuses to create hydrogen, releasing excess energy in the process. Nuclear fusion, therefore, generates heat and radiation as a byproduct, thus making a star hot and bright. Cold fusion, as a side note, is a hypothetical version of nuclear fusion that can occur at room temperature rather than at the millions of degrees inside a star. And let's pause here for a moment just to appreciate how misguided Star Trek Into Darkness is, where cold fusion is used to
You're not going to sit here and disrespect Star Trek, bro. I'm just going to be honest.
freeze a volcano into ice. Moving on, let's talk about the color of stars. The color of stars is a bit of a squirrely topic, varying depending on who you're asking. According to NASA, it's temperature that determines the color of a star. In the case of our sun, you'll have noticed it tends to appear yellow during sunrise and sunset, and somewhat bluish during peak hours. Needless to say, these perceived color variations are largely due to interference from our atmosphere. The colors implied by NASA, although accurate, are mostly only relevant assuming that you're making observations with specialized equipment. In reality, anytime you're looking at a star with your naked eye, it's only ever going to appear white or retina-searingly, blindingly white, depending on how close you are. There is, after all, a reason that the windows on the International Space Station are filtered and equipped with shutters, lest the astronauts spend most of their time partially blind and very, very suntanned. Of course, the ISS window shutters do serve another purpose: protection against impacts from potentially dangerous space debris.
All right, let's go. Okay. Yeah, I would expect that, actually. Listen, I'm learning a couple of new things on this one here, guys. Mainly, the concept of like exploding bodies, right? I never really thought that was actually a thing, but the blood boiling aspect of it makes all the sense in the world. I mean, we've always kind of pretty much heard those things, at least. I'm glad that's actually something. Well, how about this here? I'm not glad that's true, right? But I'm glad that's kind of been confirmed, at least in my head. Let's continue.
Speaking of dangerous objects hurtling through space, Hollywood sure does love asteroid belts, and who can blame them? Flying through an asteroid belt is all the excitement of a car chase, only with the added spectacle of lasers. Or asteroid belts would be exciting if the objects weren't roughly 1 million kilometers apart. Considering that the moon is 384,000 kilometers from the Earth, barely a quarter of the distance between the average asteroids in a belt, you're probably going to be okay passing through unless you are extremely unlucky. As to why asteroid belts themselves exist, they occur for a variety of reasons, but are generally the leftovers of some or other cosmic event that took place a long time ago. In many cases, interplanetary collisions will produce asteroid fields, as is the case of our own asteroid belt. The asteroid formations between Mars and Jupiter, referred to as the main asteroid belt, came about when gravity from Jupiter interrupted the accretion of planets, causing partially formed planetesimals to collide and shatter. Most of the gathered mass was lost, but some found its way into our solar system, where it remains today. So any danger we face from asteroids clearly isn't via crashing into them with a spaceship. But then again, that's something we've known about for a long time, most explicitly.
His context is pretty much dependent on this solar system. I mean, obviously, we only know this solar system. I get that, right? But in films, they're in other solar systems where, well, I guess he's right still. I mean, everything would be like super far apart. Like, you have to be a complete imbecile to specifically run your ship, let's say, into an asteroid if they're spread out, that great distance. Okay. Okay, Simon Whistler.
Since the 1970s, the Voyager space probes 1 and 2 were launched in 1977. Their mission was to provide data on distant planets like Jupiter and Mars, and we now know about the active volcanoes on Jupiter's moon solely because of the Voyager mission. It will, no doubt, not shock you to learn that neither probe was in danger of crashing into an asteroid as they passed through the belt. Voyager 1 went interstellar, passing into the space beyond our own solar system in August 2012, and Voyager did the same thing in November 2018, making the probes the furthest man-made objects from Earth. Voyager 1 sadly stopped sending.
And their propulsion systems are intriguing to me. Like how they produce energy through radioactive decay, I think it is, guys. It's super, super interesting how they did this.
Good information in November 2023, while Voyager 2 remains active and in communication to this day. As a closing thought, it's probably fair to assume that many Hollywood filmmakers are actually aware of the information that we shared here. The problem is that Hollywood is making entertainment, not science documentaries, and thus they're much more concerned about whether an audience understands the film rather than the film being scientifically accurate. On that note, do check out The Martian, 2001: A Space Odyssey, and The Expanse for far more realistic depictions of outer space.
What's funny is that, guys, I have been absolutely, a fanatic of the show Stargate SG-1, along with Atlantis and the Universe and things like that. And I've talked about it, a lot, let's say, over on my movie reaction channel. It's in the description if you guys want to check it out really quickly, guys. But either way, I talk about this a lot. And everyone is always suggesting that I watch The Expanse. But, bro, I cannot tell you how many times I watched the first episode and never finished it. Guys, let me know if it gets better, because I just can't, bro. I'm trying hard. I want to see it, because you guys always tell me that it's amazing. If you loved Stargate, you'd love The Expanse. Okay, well, tell me if it's worth seeing past the first episode, because I have started this multiple times. Multiples of times, guys. But all right, listen, guys, you guys all have an absolutely amazing day. Enjoy your day thoroughly. And if you guys are new here, please like and subscribe, guys. All right? Catch you guys later. Guys, before we go, are you guys subscribed to the other channels? Logical Movie Reviews with Mr. L. Boyd, along with Mr. L. Boyd Music. Both are found in the description. Check it out.